Hey everybody, it's Kyle from Wise Guys Tutoring. Today we'll be doing questions 16 to 20 of the Math EmSAT 2020 specimen paper, and as usual I'll try to also give you a background on each topic as we solve the question. So let's get started. Number 16 says, identify the image of point 4 minus 2 after a dilation of 3. So first thing, let's identify these. This is the x coordinate and this is the y coordinate. So let's put this point on our, I got a graph here going, so let's do it. The x coordinate is 4, so 1, 2, 3, 4, and the y coordinate is -2, so -1, -2, and you end up right here. This is our point. Let's call it point P just for, reference sake. There is a small mistake here because when it comes to dilation, we need to know the center, okay? What is dilation? Dilation just means either you're enlarging or you're shrinking. Now, since this is a factor of 3, that means you're tripling the size of something. Let's just pretend that I have a triangle, a shape like this, and they tell me the same thing. Let's say there's a dilation of factor 3, a dilation of 3. I would need to know the center. And let's assume the center is the origin, 0, 0. In this case, since they don't tell you anything, you can safely assume that it is the center here. Now, what a dilation means is if you were to take a line like this and go from your center of dilation to each point like this of your original, that means your image of each point will be somewhere on that line. Now, it'll be on that line at 3 times the distance of the original point. For example, my image might look like something like this. From here, that point would end up here, and this point would end up here. So you would get a larger triangle, technically 3 times as large. That's what dilation is, okay? This is the image, whereas that first one was the original. Okay, so in this case, we don't have a shape, we only have a point, but we can use the same idea. So if I were to take a line and draw this line straight through this point, I know that the image of this point P after dilation is somewhere on this purple line. But where is it on that purple line? So as I mentioned, when it's a dilation of 3, that means the new point, the image, will be 3 times as far from the center as the original. So you can do it in x first and then in y second. So in x, my original is 1, 2, 3, 4 units away from the center. So I'll say 4 times that factor of 3. My image will be 12 away from my center of dilation. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's the x coordinate of my image. Now for the y coordinate, I do the same thing. I say, originally it was -2, so it's going to be 3 times as far, so it's got to be 6 units away. So it's 1, 2, 3, 4, 5, 6. That's the y coordinate of my image. So if I do 12 and -6, I end up here with my P prime, which is the image of P with a dilation of 3. You can even visually see that it is 3 times as far as the original. So the correct answer would be A. Now, anytime you have a dilation, if they give you a point and you're doing a dilation with the center being the origin, basically all you have to do is just multiply your factor by your coordinates. So we could have just done 4 minus 2, that times 3 just gives you 12, -6. So that's the new coordinate of the image. Okay, let's move on to question 17. So this one says to solve this equation, which is y squared minus 3y equals 9. So let's talk about this equation. Since you have a y squared, that means this is a quadratic function, okay? Whenever you have a square variable, the highest power is a square. This is called a quadratic function. Okay, so the way you solve a quadratic function, now we have a bunch of videos on our quadratic solving series, so you might want to check out that link. But the first step is this. You need to get everybody on one side and the other side equal to 0. So in case you're not too comfortable, we also have some basic algebra videos. The way you do this is to move the 9, you do -9 on both sides, that goes away. Now what you end up with is y squared minus 3y minus 9 equals 0. Okay, now we can solve this. First thing you need to do is identify A, B, and C. Now a is the coefficient of your highest power, so the square, and when you don't see anything, it's not 0, right? It's 1. Okay, it's 1. And b can be found here. It's the coefficient of the single power, linear variable, if you will, the one that has power 1. So that's -3. It's not 3, right? The minus belongs to that 3. And this is -9. C is always going to be your constant. Okay, now that we have this, what we can use is this beast of a formula. It's called the quadratic formula. Here it comes. Y equals minus b plus or minus square root of b squared minus 4 times a times c, all of that divided by 2 times a. So it looks very bad, but if you break it down, it's not so bad. And you promise you that you're probably going to memorize this by the time you're done practicing. All right. So now that we've identified a, b, and c, we're going to slowly put them in here and see what's up. So first is minus b. So it's minus 3, right? It's negative b, whatever b is, I put it in here. Plus or minus the square root of. So you have minus 3 squared minus 4 times a, which is 1, times c, which is -9, divided by 2 times a, which is 1. So now what we're going to do is we're going to take this part here on the side. Let's do it here. This part is called the discriminant. Usually we use the Greek letter delta. So it's minus 3 squared minus 4 times 1 times -9. And the reason I'm doing it on the side is just to make my life a little bit easier. I'll calculate this and just put a number in here instead of having this big old mess. So minus 3 squared is just positive 9. I'll keep this minus here. That's what I advise you to do. Keep this minus, calculate these three, the product of these three, and then put it back and deal with the sign. So 4 times 1 is 4 times -9. That's minus 36. So now I notice I have a double negative like that, which just means plus 36. And that gives me 45. So that the whole thing under the root is just 45. So I can replace that now. So I'll do equals. Again, I have a double negative. So that's positive 3 plus or minus the square root of 45 divided by 2 times 1. That's 2. Now check this out. None of these answers fit mine, right? Now you might have seen in the previous questions that we can simplify this square root of 45. So again, I'll do that on the side. You say the square, I'm running out of space here, so I'm just going to squeeze in here. So square root of 45. I can break this up, right? And the rule is you want to break it up into a product of two numbers, one of which has to be a perfect square, at least one of them. And perfect squares, that means, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, one of these numbers. So what's the biggest one that I can make a product to give me 45? It's 9. It's 9 times 5. Now that I've broken it up into a product, I can break it up into separate roots. This is all legal, okay? Square root of 9 can be simplified into 3 times square root of 5. So actually square root of 45 can be replaced by this. So that's what I'll do now. I'll say 3 plus or minus, instead of square root 45, now I'm allowed to put 3 root 5. And I'll divide that by 2. Now that is one of the answers. As usual, it's A. Okay? I just want to clarify a little something here. So this plus minus, in case it's throwing you off, it just means there are two answers. It's one of them is 3 plus 3 square root of 5 divided by 2. And 3 minus 3 root 5 over 2. And the reason you have 2 is because this is a parabola. Well, this specific parabola opens to the right. Usually you would see it as x squared, minus 3x minus 9. That would look like an upward parabola. But the idea is the same. There are two values which cross the y-axis here. And they are right here. Let's move on to question 18. Okay, so it says choose the correct classification for the conic section below. So conic sections, there are 4 of them, so let's go through them. First one is a circle, and this would probably be the simplest one. The two things you would need to know about a circle is its center, which is located at, let's say, HK, That's the coordinates, right? X coordinate, Y coordinate. And you need to know its radius, which we call r. So the equation of a circle is simple. It's like this: x minus h squared plus y minus k squared equals r squared. Okay, so whenever you have an equation like this where x is squared and y is squared and you add them up and they give you a constant, that's a circle with center h, k, and a radius of r. We're going to see this again in question 19, and now that you know this, question 19 is actually going to be a breeze. So that's the circle. The next one you need to know is an ellipse, which is basically a stretched out circle. Okay, so the equation for an ellipse looks like this: x minus h squared over a squared plus y minus k squared over b squared equals 1. And what this gives you is an ellipse that looks like this. I'll just draw it freehand here. So it's like a stretched out circle, and this value a will be this value here, and that value b will be this value here, that length from the center to the tip, to the edge of the ellipse. And again, the center is the same. The center in this case is 0, 0, but the coordinates of the center are still given by hk. It has not changed here. Okay, so that's an ellipse that looks like this. Here's the twist though: you can have a different ellipse, a vertical ellipse, and it would look something like this: x minus h squared over b squared plus y minus k squared over a squared equals 1. So you notice, of course, this is a little bit different. Now, again, let me do a freehand drawing here. So in this case, a is the vertical part and b is the horizontal one. That's distance b. And again, hk represents the center. So if you get something like this, what you have is an ellipse. Okay. The third type of conic section will be a parabola. Parabola, which you've seen when we do quadratic equations. But let's change the shape a little bit. Let's stick with the theme where we do horizontal first. So horizontal parabola looks like this: x equals some coefficient a times y minus k squared plus h. Now in this case, it's not really a center. The hk is going to be your vertex, which is the minimum or maximum of the parabola. And what that looks like is something like this. It's a sideways parabola. Okay, with the vertex being here. That's coordinates of this point will be hk. Okay, the normal parabola or vertical parabola, which we're quite a bit more used to by now, is y equals a x minus h squared plus k. And that's the parabola that, you know, looks like that. Okay, with the vertex being right here, coordinates hk. Now the last one is the more, you know, a little bit complicated one. It's called a hyperbola. So I'll put it over here so we have a bit more space. Hyperbola. This is what a hyperbola is about. First, you've got two asymptotes, like so. Okay. Now a hyperbola has this kind of equation. It's x minus h squared over a squared minus y minus k squared over b squared equals 1. And what it looks like is this. This is again a horizontal parabola, hyperbola, pardon me. Looks like this. So these are asymptotes. That means the graph will never ever touch those. And this here is the center. And the center, once again, has the coordinates of h and k. For now, all we're gonna pay attention to is a. A is this length here, from the center to the vertex. It is symmetrical about the origin, so this would also be a, if you will. Okay. Now again, this is the horizontal hyperbola, and as you can imagine, you can have another one. Maybe I'll just draw another graph here, like so. So again, you put your asymptotes like this through the origin, and the equation for this hyperbola will be y minus k squared over a squared minus x minus h squared over b squared equals 1. And it would look like this, where again hk is the center, and in this case a is from the center to the vertex, or to either vertex I should say, since there are two now. Okay, so now you have all the equations. So this is what I want to show you guys. The difference is, for a circle you will always have x is squared and y is squared, and there will be no denominator. That's how you can kind of recognize it. You can get it into this shape, okay, where they both equal a certain constant. In an ellipse, they will be arranged in a way like a circle. However, because you don't have the same radius in both directions, you will always have both of them divided by a different denominator and equal to 1. Okay? The way that you're going to know if it's horizontal or vertical is which side is longer. If A is a longer side, let's assume, the longer side is under x, that means it's a horizontal. And if the longer side is the denominator of y, that means it's a vertical ellipse. For a parabola, it's actually the easiest one to recognize because only one of the variables will be squared. If y is the one that's going to be squared, that means you have a horizontal parabola. And if x is the one that's going to be squared, that means you have a vertical parabola. Now, I just want to mention, hopefully you already know this, but a parabola can open to the right or to the left. This will happen when a is less than 0, and this happens when a is positive. This one is when a is bigger than 0, and you get a frowny face if a is smaller than 0. Again, you can check out our videos on quadratic equations, quadratic functions, and all that is in there. Lastly, the hyperbola. The way that you're going to tell which one is a hyperbola is if you have both of them are squared, but you have x minus y or y minus x. So I'd like to compare that to the ellipse. If you notice, this one you're adding the x squared and y squared terms, whereas in a hyperbola you are subtracting one from the other. If it's x minus y, then you get this horizontal shape, and if it's y minus x, then you get this vertical shape. Okay. Lastly, I just want to stress the center of the circle. I never drew the circle, but it looks like that. The center is HK, and in this case also the center will be HK. Okay. In the parabola, it's the vertex has the coordinates of HK. It's not the center, it's the vertex has coordinates of HK. And in a hyperbola, again, it's the center has the coordinates of HK. Okay. So getting back to our question, I can look at this equation and say that only y is squared, and therefore it's definitely going to be a parabola, right? Because all the others have two of the variables will be squared. So this is a parabola, and since y is the term that's squared, I can actually even say that it's a horizontal parabola. So there you go. Let's move on to question 19. So question 19 says, which equation represents a circle whose center is 3 minus 1 and whose radius is √6? So as we just saw, when you have a circle, the equation is always like this. It's x minus h squared plus y minus k squared equals r squared. So in this case, the center, we know as per the circle equation, the center is always at hk. That's your center, and the radius is always r squared. You take that and you're going to square root it to get r. Okay, so we look at these equations here. Which one of them will suit? Well, if the center is 3 minus 1, that means my circle equation must be x minus 3 squared. Okay, and if it's the y value of the center, the y coordinate is -1, that means I have y minus -1, which becomes +1 squared. And if my radius is √6, I have r squared here. So if r is √6, then √6 squared just gives me 6. So this one would be exactly matching with A, and that'll be your answer. Let's move on to question 20. So question 20 says, if measure of angle A is 35 and B equals 3 and A equals 4, how many different triangles can be constructed? So here they're kind of assuming that you know what the shape of the triangle is, basically we always do these problems like this. You have a base side, and then you have one side here which we usually call B, and you have a third side which I'm not going to draw right now. So this is the way it works. Let's call this angle here angle A, and we'll call this side here B. There's always a third side here which we call A, but see, A can be different ways. You see, A can come straight down for a right angle triangle, or A can be something like this, where you would have one of these obtuse triangles. It has a angle bigger than 90, so this is an obtuse angle. You can also have one of these triangles, something like that. That's again an obtuse angle. Or you can have a triangle that doesn't exist. Maybe that side A is super short and it doesn't exist. So what I want to show you is how we figure this out. So to do that, we're always going to be comparing to the height. Okay, maybe we'll take a light blue or something. The height of a triangle is the distance from the vertex to the base, and it's always coming at a right angle. This is the height of the triangle. Let's call it H for simplicity's sake. Okay, we're always going to be comparing that third side A to H and to B. Now, how do we find H? So you'd have to know a little bit of trigonometry. If you're not sure, you can check out our other videos on that. So sine of that angle A is equal to the opposite side, which is H, divided by the hypotenuse, which is B, that long side. So if you do a little bit of algebra and you want to get H all alone, you would multiply both sides by B to get rid of this B, and then you would get your equation for H. So B sine of angle A is equal to H. Now that we know that, we can compare our third side, which we will call small a, and we'll compare it to H and to B, and we'll see what kind of triangle we get. I'm going to show you guys the 4 cases that we have, okay? Starting with the first. So here we go. Abracadabra, boom, triangle right there. So as we said, this side we'll call it B, this angle we'll call it A. And we already know the measure of this one. They told us 35 degrees, and we know that B is equal to 3. And this side, that third side, will be equal to A. So this is the first case, okay? I'm ignoring this one because I just want to show you what the 4 cases are. In this case, A is shorter than what H would be, right? Remember, H would be the height of the triangle. In this case, A is shorter than what H would be. It's shorter than B sine 35. So if this is the case, then no triangle possible. There are no triangles possible, okay? Because it's too short. It won't even close. So we can check this, okay? H is equal to B sine A. That means it's 3 times sine 35. And if we put that in the calculator, you get about 1.72. Now, in our case, obviously, A is bigger than H. So we don't have this case, okay? So D would be a wrong answer. Now let's go on to the second case. So in this case, again, I'll put B here, and I'll put, A, the angle A is here. That one is 35 degrees, and that one is equal to 3. And this side would be A. As you can see, this is a right angle triangle if A is equal to H. Again, we already know that H is 1.72, so we know that A being 4 for our case, it is not equal to H. Therefore, we do not have a right angle triangle. So B is also gone. Okay, so for this case, when A equals H, you get this one right angle triangle. Okay, let's check out the third case. This is the third case now. So again, I'll bore you and put these angles. I probably should have done that before, but come on, I already prepared the triangles. That's quite a bit of work, right? Okay, so in this case, A would have to be longer. Okay, in this case, A is longer or equal to B. So for our case, when B is 3 and A is 4, we are in fact longer than B. So in this case, one obtuse triangle is what you're going to get. Okay, so in this case, we don't compare it to H, we're actually just comparing it to B. So the answer is A, but just in case, I want to show you guys that fourth one, which is 2 triangles. Okay, so here's the case with 2 triangles. B is 3. You already know the drill. There's angle A. Now, in this case, in 2 triangle case, it happens when this. It happens when A is bigger than H but also A is smaller than B at the same time. When these two conditions are met, this is what happens. You get something really interesting. You can get this triangle here, or you can get another triangle. It's the same side. Say this is A. Say this is A. You can also have another triangle where A kind of swings over as if it's hinged on that side. It keeps the exact same length, as you can see, and now you have another possibility. So now you actually have two possible triangles. You see, when A is smaller than B, yet it is longer than the height H, you can have two possible triangles. This may be a little bit hard to see, so maybe I can trace the two triangles. It would be, this is the first one right here. And then imagine that this arm A were to swing around this way, while being hinged at this point, then it would still connect with a longer base. The base does get longer, that's true, but A is the same and so is B. Then you would have this triangle, this larger triangle. B stays the same, the angle A is still 35, and the length of little a is also the same as it was in the pink. However, you have a second triangle. So this is the case where you have two possibilities. It's when A is bigger than H and A is smaller than B. Again, that is not our case because A is larger than B. It is not smaller than B. That's why this case is not correct for us. So that's it for this video. Join us in the next one where, of course, as you know, we'll be doing 21 to 25. And if you have any questions, comments, suggestions, please leave them for me below. And, I'll get back to you as soon as I can. I'll see you guys in the next one.